So I'm looking at number 2. Swimmers on a 4x1 relay team swim 100 meters each. Their individual times are totaled to form their overall team time. Particular team records how long it takes each swimmer to complete their portion of the race each time they swim 100 meters in practice and competitions. Individual swimmers' times are independent of each other. So I know Allie's average and standard deviation from all their competitions and practices. Same for Layla, Carmen, and Sharifa. So T is going to be the total time it takes to finish it, which means Allie has to swim 100, Layla has to swim, Carmen, they all have to do it. And I'm just essentially adding their speeds or their time, I guess. So that means if I want the average time, I can think about the fact that that's just the average of the sum of Allie's score, or I keep saying score, time, Layla's time, Carmen's time, and Sharifa's time. And we are allowed to add distributions if they are independent of each other. So I could take Allie's average, add on Layla's average, and Carmen's average, and Sharifa's average. So that means I'm just going to get to take 65, 60, 70, and 55. So summing their average tells me that the average relay timing should be about 250 seconds. Standard deviations are different. You cannot add individual standard deviations, but you can add the variances. So I will find Allie's variance and add it to Layla's variance and add it to Carmen's variance and add that to Sharifa's variance. So I'm going to just take 2 squared. This is the one that looks like the Pythagorean theorem. It doesn't look as much like it now because I have 4 terms underneath my radical, but I'm just summing my variances and square rooting, and I can find that the typical distance from 250 seconds would be 7.35 seconds.